Okay, so now we're gonna see the compound interest calculations. We're gonna create a new folder and we can just name it test for now. So we're gonna right click and we're gonna open in terminal. So we're gonna type in code, space that, so we can open it with Visual Studio Code. And we're gonna have this particular problem. So we're gonna have that a person invest and is gonna invest $1,000, okay, in a savings account, like that, yielding 5% interest. Okay, it's gonna pretty much yielding 5% interest. Okay, we're gonna have that, and let me see if I can make this one bigger. Okay, so assuming that all the interest is left on deposit, so we're gonna assuming that all the interest is left on deposit. Oops, let me see. Assuming that all the interest is left on deposit, we're gonna calculate and print. So we're gonna calculate and print. The amount of money. Print the amount of money. Okay, and the account at the end, of the of each year for 10 years, like that. Okay, so and we are gonna use a particular formula that is gonna be A is gonna be equal to, and we're gonna have a sum here, and it's gonna be 1 plus r, and this is gonna be raised to the n power, and this whole thing is gonna be multiplied by p. And pretty much we have that p is gonna be the original amount invested, the principal, so we can put like that column. We're gonna have the principal like that. Then we're gonna have that r is gonna be the annual interest, so it's gonna be the annual interest rate. Then we're gonna have that n is gonna be the number of years, so it's gonna be number of years, like that. And finally a is gonna be the amount on the deposit, the amount on the deposit at the end of the nth year. Okay, so we have that so far. Let me see. Okay, so now we have the formula. We have A is equal to the this is not right. It has to be like this. Okay, A is equal to the product of P and the sum of 1 plus R, and this whole sum is going to be raised to the nth power, where P is the principal, R is the annual interest rate, N is the number of years, and A is the amount on the deposit at the end of the nth year. Okay, so now with this information we can start writing our code, and we are gonna name it. Okay, let me see this file. We are gonna name it, okay, sum. Okay, it's gonna be just like, no, it's not gonna be sum, it's gonna be interest, like that, interest.java. We can close this one, we can close here. Okay, so we're gonna use the compound interest calculation with the for statement. So we're gonna have this public class, and it's gonna be interest, like that. Okay, here we are gonna have the public static void, so we're gonna have the public static void, and we are gonna have three variables: amount, principal, and rate, that we already saw here. And let me see if I can make this one a little bigger. Okay, so we have three variables. It's gonna be the amount, the principal, so this is gonna be the principal. Okay, we're gonna have the rate, so it's gonna be R, and we are gonna have this one, the amount on the deposit at the end of the nth year. So this is gonna be our variable. So now we need to type the type of these variables, and the type is gonna be double. Okay, it's not gonna be integer, it has to be double, because we're gonna deal with decimal. So just something real quick. Java treats floating point constants like 1000.0 and 0.05 as type double. Similarly, Java treats whole numbers constants like 7 and -7 as type integer. So that's the reason we're gonna use type double, the variable amount. So this is gonna be amount on deposit at the end of each year. Okay, so we just gonna let it like that, amount, double amount, then we're gonna have the double principal, okay, and we're gonna set it to 1000.0. Okay, semicolon at the end. We are gonna have the double rate, and we're gonna set it to 0.05, semicolon at the end. Okay, this is gonna be the interest rate. We have the initial amount before interest, so $1,000 is the initial amount before interest. The rate is gonna be, the interest rate is gonna be 0.05, and this is the amount on deposit at the end of each year. Okay, we have that so far. Now we're gonna use the System.out.println, and we are gonna change it to printf, because we're gonna have arguments here. Okay, so we're gonna have three arguments, and the first one is gonna be, we are gonna have the %, lowercase letter s for stream. Then we're gonna have the %, we're gonna set it to 20 stream to the next line. Okay, and then comma and comma again, and this argument is gonna be the year, like that, and the final argument is gonna be the amount on deposit, like that. Let me see, year, amount, the deposit, everything is fine. Okay, so we're gonna calculate the amount on deposit for each of 10 years. So we're gonna use the for loop. So yeah, we can do it like that. And in the for, we're gonna have this integer, and it's gonna be, okay, this variable is named year and is of type integer. Okay, and we are initialized to 1. Okay, we're gonna put the condition, as long as the variable year is less than or equal to 10, we're gonna let me see, we're gonna increment the year by 1. Okay, and we're gonna calculate the new amount for specified year. So the amount is gonna be set to the principal. Let me see, it's gonna be set to the principal. Okay, and we're gonna multiply it by math. Let me see, math.pow. Okay, math.pow, and here we are gonna have okay, principal, let me see, principal, okay, principal, like that. We're gonna multiply it by math.pow, and we are gonna have, they already give me that, but what what I want is it's gonna be 1 plus the rate, so we're gonna have 1.0 plus the rate, comma, the year. Okay, so we can have that. And here we are gonna have, let me see, I can move this one. We are using, well, I can do it here. Okay, so we are using this one, the math.pow. This is a static method pow of class math to perform the compound interest calculations. Okay, so this is pretty much like this, and you put x and y. Okay, so pretty much we have the math.pow, in parentheses we have the variables x and y. So this calculates the value of this variable x raised to the yth power, or y superposition th power. So this would be x raised to the y to the x to the yth power. So it'll be like x, and then we would raise it like that, and it'll be to the y power. So okay, that's what this method does. Okay, so pretty much the method receives 2 double arguments and returns a double value. Okay, so we can leave it like that, and now we are gonna continue. So semicolon at the end, and finally, okay, so we have the amount is gonna be the principal, the rate, and the year. Okay, so now we are gonna have in the System.out.println, and again we're gonna change it to print format. So we're gonna have let me see, we're gonna have the display the year and the amount. So percent sign, we're gonna have 4 decimal or digits. Okay, we are dealing with integers at this point. And now we're gonna dealing with double, so we're gonna pick 20.2f. So the lowercase letter f we deal with is for double, and lowercase letter d is for integer. So next line, and then we're gonna have 2 more arguments that are gonna be the year and the amount. So it's gonna be the year, and here is gonna be the amount. Okay, so let me see amount. I type it, yeah, amount, double amount. So the value of local variable amount is not used. So let me check something real quick. We have the rate, the principal, the year, principal, amount. Okay, this is inside here. Oops. Yeah, this is not a string, and pretty much I'm turning it. These are strings, year and amount, but these has to be the variables themselves. So okay, so now everything looks fine. Okay, so here we need the percent sign, and now let's see it, and now it's working. Okay, so pretty much here we have the percent sign 4, and then lowercase letter d. We can make it 3, so instead these numbers is gonna be in this column towards the left. So check it out, and yeah, it can be like that. Okay, and instead of 20.2f, we can lower it to 15.2f. so this whole number goes to the 5 digits towards the left. Okay, so we're gonna see it, and as you can see, 1, 2, well, pretty much is occupying all this space. So 5 digits towards the left, and you can play around with these values. I don't know, maybe put it to 16, and this one to 2. Let me see. And as you can see, the year is gonna be, the first year the amount is gonna be 1050, then it's gonna be 1102, then 1157. So pretty much this is in accord with the problem that we have. And just to remind you, pretty much for the problem, a person invests $1,000 in a saving account yielding 5% interest. Assuming that all the interest is left on deposit, calculate and print the amount of money in the account at the end of each year for 10 years. So at the end of, let me see, at the end of year 1, we're gonna have $50 of interest. At the end of year 2, we're gonna have $102.50, and so on and so forth. Okay, what else we have here? And pretty much, yeah, this is the formula here. This is the mathematical formula, where A is the amount of the deposit at the end of the nth year, P is the principal, okay, the principal or the original amount of money invested, and then R is the annual interest rate, and finally N is the number of years.